Okay, so we have a dodgy pump, it's powered on. Let's move that away. Let's power the shower off. Turn the mains water off. Got the cold here, now it's off. The hot is off. So now if we power it on, no water will come out. Yeah, let's power it back off. So we've got the water and the power off. It's definitely this that was leaking. This was hammering. Let's see. Yep. See? I'm going to turn the water on from the tap and then stop it. It's the pressure. So that's the hot water. Then I stop it. Remove this. You might need a prying tool like a flathead screwdriver. Then unscrew the top, bottom, and the rest you can unscrew with a drill. Just don't tighten it with a drill. Now, as I mentioned, the water mains and power is off. Disconnect this connector. And now we start unscrewing. So first of all, this has got a brown wire here that goes to the pump. Disconnect that so you have a bit more room. Unscrewing. And I drill that. 1, 2. Then the pump side. Pretend there's one here. I already unscrewed that. We would unscrew it here from the pump on both sides. The hose. And now that should come down. So now you can remove the pump. Move any drill away from that because there might be some water in this. So you remove it by prying it like that. And then gently pulling this out of this socket. See, got water. The earth wire to the side, disconnect that, and a white wire to the back here. Pull that out, and now it is unwired, and now you can have it here. So this side is disassembled, so we've got the pump. Now we just need to disassemble this piece. Now to disassemble this, so this is slightly different because I already have mine modified, but all you have to do is just unscrew the screws. On the original model, there's only 4 screws. I really advise using a magnetized driver. That way there's less chance for the screw to get loose. Now that it's unscrewed, we can get it off. Here we go. And that's that. And now, if we want to disassemble this further, we use maybe a finger, and we need to snip this, not snip it, move it out. Okay, and just make sure you don't lose it. So there we go, got that. Grab it. Okay, put it aside, and then you can take the top off. There we go. Got this spring here that was pushing up against that plastic piece before, and the one under it, which is supposed to like make a tight seal. There we go, there's a tight seal under that. And then to deconstruct that further, another drill. Now this screws into the metal bracket, metal frame of the motor. And that's loose now. There we go. And that's disassembled. The whole reason was I'm actually not replacing the whole unit with a new one, because I would have to relocate all the plumbing pipes or the copper pipes, and then for all I know, a few years down the line that one's going to break as well. So I'd rather keep the same one and just improve the design of this one if it does fail. These 4 screw holes, which was what kept breaking, these areas, these 2, I find that 4 of them are just not good enough for constant pressure, so I decided to redesign it even further to have 8 holes in total. Just redesigned this, so this way we have a perfect seal with 8 holes in total. So this is the piece that I scanned initially, and then I modeled on top of it. It would go inside, the rubber O-ring would go in here, and then it would go on top. This piece, when put up against the rubber O-ring, it doesn't actually squish the rubber O-ring, it sits on top of this area, so the rubber O-ring doesn't get squished. The squish comes from this side to this side. So before we do any assembly, I am gonna do very light sand with 800 grit. And this is just to get rid of layer lines just on the inside where the rubber O-ring is going to go. Just a few circles, just a few rotations, I mean. Because we don't want to actually reduce the size of it, we just want to get rid of the layer lines, and that's good enough. And for this, don't really need to do this. Also, this is printed with 0 supports on the inside of the actual functional areas, so this is why it looks rather good. Start off with cleaning with IPA, isopropyl alcohol, and I'm gonna seal it with some Fernox sealant, but you also want to make sure you don't seal the area that is supposed to move, which is the pump itself. And for the inside bits, I'm going to use cotton buds, so same here, isopropyl alcohol, and then cotton buds. I'm just going to twist them. And then bin each one, and then use a new one for new areas. So this is our first area that we're going to seal. Now if you're using an extreme resin, I'm using ABS-like resin. I think the problem with this is ABS resin, there is a slight flex to it. So I think that might be a problem with this, which is why I'm needing to seal it. But if you use a tougher resin, maybe like dental resins, you might get away with it. but I think I need to use a sealant. So the first rubber O-ring is here on the actual pump piece itself. I don't know what this piece is called, but yeah, so this actually doesn't have any push, so like once it's pushed down in this position, there's nothing to push this ring up into this piece, so it goes here, and you can see the rubber O-ring is going to get squished, and once it's squished, it doesn't really come back up. So we pretty much can ignore this anyway, but I'm going to clean this up, even though it's not really necessary. Oh, just a bit of IPA. And no sealant here because, as I mentioned, that area is going to move. So that goes on. And let's just have a look at how this is constructed. Watertight bushings. Are they bushings? Seals. How do I remove this? From the bottom side, I think. There we go. It goes this piece, which is actually a rubber piece underneath, and this comes out. This piece is made for friction because this is what goes on this piece, and the area here inside is nice and tight with this metal piece, and the seal is made by the rubber, outside rubber and the bottom rubber to the bottom of this and the side of the inside. So it gets pressed up to the very bottom here, and then a seal is made not by clamping around this, because you see it's this loose around that, but by the force that is applied to the bottom of this to here. And you can see this, however, it is tight around the metal piece, and then the squishing of this, you push this against, and that is how the force is created and holds the piece in place. But before we do that, I'm going to create that seal with the sealant. So you can see I pushed that out, however I didn't push the rubber out yet. So let's get the rubber. See, the rubber is stuck in there. So I cleaned the inside with IPA. Now I should clean this rubber ring with some more IPA. Just do that. Okay, that's good. And this piece goes on top. So I should not really touch that because now my thing is a bit greasy, but let's get some gloves on. So we can do it at the very bottom of this. Not too much, that's quite a lot as it is actually. So let's spread it with this cotton bud. All around, so on the outside circle and the bottom of it as well. All around. Okay, that looks perfect. Put that away for a second, and now we're going to push it down. And I don't want any at the top of it, so just the bottom. So we can squish it down. And now I want to be a bit careful because I don't want, as I mentioned, on the top. So I can start getting rid of excess and bin it. And now I'm going to push it in. Going to squeeze out all that excess. See all that? And now more cotton bud. Get rid of that excess because I do not want that touching anything else. Actually, we can use that excess and put it in the washer area because I want this area sealed as well. I'm not going to repeat using that, so I'm going to do this. Get rid of the excess in this hole, and I'm going to push it in one more time to make sure it's a nice tight seal, which it is. just going to clean it up now actually. So anything that you can see now can be cleaned up because the bottom and the sides are pretty much sealed now. When this piece is on the motor area, it spins rapidly, so it can cause friction against that somehow. I don't know what or how it works, but that's what it does. Now this doesn't have to be too clean because there is quite a wide gap between this area that I'm cleaning now and the motor piece, so you don't have to be too over the top with the cleaning. But in the meantime, I can put some more in these holes now. Actually, let's just go on ahead and put it in on top of that now. So let's remind myself. So the back of the motor is where this blue wire is, so that's the back, and this is the front, and this is going to the right, so it will be like that. So yeah, it will be like that. So I'm just gonna lift this rubber a bit higher so I can squish it in place, even though there is nothing to squish against really. But before I do that, let's fill these holes up with the sealant. It's a bit much, but that's fine. Also for this area, if you have, say, a large rubber ring, originally only the small rubber ring comes on this area, on the actual area that turns. However, if you have something like this, you could put this on here, and that would close the gap between the inside here to the top. So if we put that on top, it will create a very nice closing area kind of thing. To be honest, this rubber O-ring is irrelevant because there's no squishing, so I might as well take that off and replace it with the other one, I believe. Might be wrong, but let's try it. Well, I'm just gonna maybe leave the both on, but I just don't want them having friction between one another, so let's try it like that. So there's water above here. I wonder why that is. Oh, okay, so it's powered on. Here we go, like that, and now we can put the metal pieces in place. You can see we've got this green kind of washer, and that is like a sealant itself. Might as well push that back in to make it even a greater seal. Since I got so much squishing out anyway, might as well go around it. I'm doing it half at a time so I don't push any, or maybe just wipe it. Don't want it in the actual screw hole. Fine for me. Okay, so at this stage there is still a leaking point because we only got the rubber ring around that. It's not actually making the seal to the metal pole, it's making the seal to this, the bottom of this and the sides of it. However, we're not going to apply any more of that sealant. We're just going to clean it with IPA instead. Because as I mentioned, the seal is made from inside here to the bottom but I do want it cleaned very well. So I'm going to use more IPA, clean the inside of this. See, dirt really builds up in this place. But make sure to dry the IPA because that sealant is still drying. Okay, now it's ready to be mounted. Actually, in the meantime, you might as well clean the metal rod itself. Make sure there's no dirt or anything on it. Hold the rod in place. Okay, now it's ready for it. So remember, the bottom of it is going to make contact with the bottom of that. So push it on. And what's going to hold it in place is the thing that actually makes the pump push the water around. So again, clean this as well. IPA and the top. Push it in place. And now remember, this is what's going to cause the pressure. Pushing it like that. We can push it so it holds its position with this metal washer kind of thing. There we go. And they should have a tight seal now. So let's continue with this, with making the tight seal around this area now, the inside to the inside of that. Okay, so on to the next piece. So we're gonna fit this into that, but before we do that, let's just give it a quick clean with IPA. Okay, right, let's pop it in place. So like that, and push it in nice and tight. Well, it's rather loose, not tight, but I like to push it in like that. And then I'm going to have the large rubber O-ring, which is going to sit inside here. But before we do that, I want to put the Fernox sealant around it. So let's just make sure it's super dry with IPA. Then a fresh piece of kitchen roll, make sure it's dry. And now we're ready for the Fernox. So all around. Oh, if the Fernox is not spreading, that means that area is dried of the Fernox, so get rid of it. Okay, and now I'm going to use a cotton bud to spread it. I'm going to get rid of the excess in a bit after the rubber O-ring is inserted. Okay, so now the rubber O-ring. Now squish it down. And you see here, that's where water comes out, so you want none of the sealant there. So let's get rid of it and put it on top instead. So we're going to move it out and on top instead. And it doesn't matter if it gets to this side as well, because that's going to get squished anyway. But where I don't want it is below the rubber O-ring, as in where the water is going to move around. And as I mentioned, get rid of the excess from the side. I don't want it in the sides. Okay, now it's ready for the upper piece. And then dry it with a dry area. Now we're ready to close it back up. So look for the notch. Notch is here on the other side. And I'm going to turn it into position. So I'm not going to push it, I'm going to turn it. There we go. And then for the notch to align, push it. Now we can, but yeah, so I'm not concerned about any area snapping off or coming undone. What I'm slightly worried about is expansion with ABS-like resin. From my experience, ABS-like resin doesn't really snap. It's like I tried hard to snapping it and it's really hard to snap. What it does do is flex. So I'm wondering, with the water pressure, is flexing going to become an issue? Okay, that's all 8, so let's get it tighter now. Not fully tight, just a little bit at a time. Because if you tighten it too much, then you'll lose the thread, and that's not what I want. But we've increased the durability by a lot. There was only 4 screws from this side from the original design. So I am hand tightening this because I want to feel how tight I'm doing this. And we are done. Yeah, so now we can fit it to the shower. Okay, so got the water on. I see a little leak, I think. I do see a little leak here. Why is it leaking over here? I want to use PTFE tape for these areas instead of the sealant. This area moves, so I want to try this to see if that is a better idea or not. I can always redo it if it is not a good idea. So it's a bit awkward actually around this area. So from what I read about PTFE tape, it is there to fill in any irregularities. So, and a 3D print like this would make very good sense to use PTFE tape on this, for example, because a 3D print like this has layer lines. Okay, so that is good. But now we need to put on the rubber O-ring. And this will give us actually a bit of more thickness, even though sure I could just increase the thickness of the 3D print itself, but the irregularities will still be there. So let's see how this will go out. And I'm not using a very long strip, I'm just using like that much. That is around what, 15 centimeters maybe. Okay, rubber O-ring, twist in position, and now it's ready to be put on. White wire goes to the back, get it out of the way, green here, and from the front we're going to twist it into position. There we go. Wires to the front now. Oh, came out the slot. There we go. Keep the white one at the back. Okay. We need to angle it a bit. About there we go. Lastly, this one. We need a little bit of angling. So this piece originally is actually rather weak as well, which is why I redesigned it with reinforced sides. But just for demonstrational purposes, I'll show you how it is held in place. So as you can see, this bit, all it does is just hold this piece in place. So water comes in from here, the top, and then it goes to this from the side here. No, that's where the water comes in from. And then water goes to the back and into here to the side. And this piece is what rotates to mix between hot or cold. So you can see water goes from either the top, and that's the cold going to here, hot going to the further back, or if you have it from the bottom here, the hot going to there, or the cold going to there. And you can see at the very back, that's where the water travels, from the back to this. And this is what mixes them together. You turn this. So this goes only one way. There is a little cutout at the bottom here. And that cutout goes at the bottom, you can see, like that. See that it's flush here. So remember the notch and the hole for the notch, and push it into this. Okay. So this piece is printed in PETG, so plastics rather than resin. And I designed this before I even had the resin printer, and this piece actually worked really well. So it didn't really need version 2. So this is really good as it is. And now we can tighten them, not over tighten them. And that should be good. So now we can just turn the water on. Okay, so if we have a look, the water is turned on, the cold and the hot. If we turn the shower on, it works perfect. 0 leaks in this part anywhere. Which is great. However, there is the tiniest drip over here, which I assume is coming from this side. Hold on, let's just turn the power off. No, power for the shower. So we can disconnect this. So, I think this is coming from around this area. It's very hard to find it because it's such a small drip. The biggest concern was this, and there's no leakage there at all, so we need to find where this is coming from. You can use this like a blower to get rid of all the water. And I'm just doing that to get rid of the previous water that was there, but caused by improper installation, because I'm still experimenting with this. And now we can have a look while the water is on, see what's going on, if there's any live leaks, and we could just leave it like that, maybe for an hour or two, and see if we get any dripping at any of these points. This serves no purpose right now, so if we undo this, we'll see that nothing is coming out, unless maybe a small drip is coming from here. So we've got the rubber O-rings here. we have water here. So now I can just leave it here for like half an hour and see if water appears here. Okay, so the water is still on, but as you can see, where we took out the rubber O-rings and the stopper, you can see that there is a bit of a water buildup here, which is clearly coming from the cold. Now why is that? Because water comes in through here, and with an option of coming in from here as well. However, when this one is not in use, these two pipes need to be blocked from water reversing down. So I do have another one. I have a donor unit. I bought this as a broken piece, just so I could disassemble each part and understand how it works. So here we have the same piece, and if we look at the bottom, we have two seals. So this is what prevents the water from reverse flowing from the middle point back down. So clearly the middle piece here, which we can see actually from the bottom, you can see there's a little stopper there. So if we've got a little bit of pliers here, so the cold, it's coming in from the cold. So we use the pliers, bring it out. You see this is the rubber O-ring that is supposed to keep the water from flowing in reverse. Now it's clearly not doing this job well. So I'm going to disassemble it one more time and seal that area as well. Okay, so that is loose. Okay, I can actually do this now.
check the rubber O-rings, yeah.
They're in place. Okay. Now we fixate all of these in position. Another reason why I think I may have had difficulties reassembling this, the middle piece and the bottom, is because of these wires as well. So they are right behind the top and the middle part. So when you put it back together, instead of clamping down on the rubber, you might be clamping down on the wires. So that is something that you really need to watch out for, because you might be clamping down on the wires instead. Previously I had the O-rings inserted into the bottom of this and shoving that on top of this, but instead this time I'm going to try having the rubber O-rings on these pieces and putting that on top. And maybe I'll put some PTFE on these as well, just to see if that improves things. So I had to detach this completely, because when this is attached to where it's supposed to go, like the only way to attach this, and this piece together is by like folding them in like a bridge. And when I do that, I don't think all the bushings or the O-rings join completely properly, so I had to unscrew it all. So I'm going to basically be able to now push it in place. So once all pieces are aligned, I'll still have a little gap, so I won't have to actually squeeze them in like that. It'll just shift in place. But that did mean I had to unscrew all these screws, and then I'll have to reposition it all. So there. So basically, if this was attached to the frame, I wouldn't be able to put it in straight like that, because if they are like squeezing in place, it won't align the rubber O-rings, I believe. Hopefully, at least, that's what I believe is true. So now, and I also put the Fernox sealant on every single rubber O-ring. So maybe that plus the positioning will get rid of this problem. So I want this up here, get those out of the way. So see if I can push it in place now, hopefully. There we go, they're pushed in place very easily now. So now I need to make sure I don't bend them and get it into the correct position, which is a bit tricky because this is sitting. I need to lift it, I think, a little bit. Oh, see, I bent it already, but I think that's okay. Nope, see what I mean? I think this is what happens. See, when you bend it, the rubber O-rings lose their position, so you can't bend it at all. And this thing that doesn't have any Fernox, so that's okay. So where was I? Need to put that in place. Need to lift this. No. Wires in the way. There we go. This is really difficult because those pipes are pushing down. Fuck me. There we go. Nearly there. Something's preventing me from moving further. Okay, it's in the correct position now. So if I tighten it, is it in the correct position? No, it's not. Where does it need to be? Oh yeah. So now it is in the correct position. So now we can fasten everything in place. But yeah, you see, this time I didn't like push them in place. So hopefully That should resolve the issue. I originally bought this power shower because my old boiler's pressure was really low and the boiling water would take around half an hour to an hour to heat up. So I bought this power shower to increase the pressure and maybe heat up the water, because I think that's what it did as well. It heated up the water itself. It didn't need a boiler. I think, I might have been wrong, but the pressure was one of the reasons why I introduced a motor to the system. But now that I've got a new boiler, I don't exactly need this, besides it's giving me issues. So what I'm going to do is I'm going to bypass the pump completely, this motor. So I have two different pieces here. So this is what I had previously, and I printed out two more. This one's side broke off, so I reinforced it with a bracket in a way. But I'm not going to use this one. You can see the difference here. This one goes to the top side, which is this thing. It lets this be inserted into that, so it can actually mix and have the pump move it all around. But I'm gonna remove this whole mechanism altogether, because you can see this is completely empty now. So all it does is let water through here and go through here. The water isn't going to be going out here at the top, and once it's sealed like that, water won't be here, so there won't be water leaking out of any of these anyway. All I'm going to be turning the power shower into is basically just a mixer. So the on and off switch, all it's going to do is open the valve switch on and off. That's all it's going to do. And of course mix the hot and cold to the temperature that I desire. Let's remember this, the notch is down here. And that is the back. So it goes like that. So we don't need to worry about any sealant or anything like that this time. So let's just use these bolts. You can see there was, I used sealant before, that Fernox stuff, but for this side I won't need it at all since I'm bypassing it completely. Now, as I mentioned, I'm not going to over tighten it either. I have the drill screwing adjustment on my drill with one, so it doesn't over crank it. That's the right word, crank. Over tighten it. I don't want to over tighten it. When I feel a little resistance, I'm going to tighten it by hand. Same with here, there was Fernox here before, so I need to get this piece out somehow because it's sealed in place. I shouldn't really be using this because this might puncture a hole in the rubber. even though, like I said, I'm going to be bypassing this area completely. You never know, in the future I might want to use it for some reason, even though I probably won't. Get rid of that sealant. This goes on top, like that. Down the bottom. There we go, done. So align the notch with the notch hole, and you don't need any sealant this time because it's all contained, and we can just start screwing all the pieces together. We actually don't even need to utilize all the screws. We do need, however, the PTFE tape. We might not need the Fernox, but I do want to have PTFE tape. PTFE tape is great. So let's do it first before the rubber O-rings. And like I said, this is mostly to fix the inconsistencies that you might get during a 3D print. And since it is resin print, so it is much more detailed compared to FDM plastic, it's still built of layer lines. So that is what we're getting rid of with this PTFE tape, those inconsistencies of the line. And remember, this PTFE tape also acts as a lubricant, so that's a very good contribution. So yeah, twist it in the same direction of the PTFE tape. That'll do, and it's ready for mounting. But to bypass it, all I'm going to do is insulate each of the wires that went on the motor, so we're not going to use any of the wires. So let's start with the insulation of the wires. And there's only 3 wires that we insulate that was attached to the motor, and we're not going to anymore. So the white wire, and I'm going to fold it around. And you can see that they are all different lengths, so they shouldn't come across each other. But you can push them to a side so they don't intersect. The rest is the same method for joining them all together. So yeah guys, thank you very much for watching all these videos of the power shower and me learning about it. But yeah, I thought it was a very valuable lesson in learning how it works inside out. I didn't want to go and buy another power shower in case the other one broke and then I didn't know what was wrong with it, wouldn't know how to fix it. So I thought might as well stick with one and learn it inside out and improve upon the design where there's faults. So yeah guys, if you want these files, they will be up on my Etsy. Grab them now. There's going to be around 4 different files. You've got to get this, the pump enclosure, pump base, mixer enclosure, and then I got a pump enclosure hoove. If you don't have a resin print, or if you don't want a resin print, which will be a temporary fixing method for the original piece, if you super glue it back together and you want to put a little hoove on top of it to maybe have some more structural integrity for a temporary time being until you get it resin printed with this better enclosure. So yeah guys, thank you very much, take care. But now I've got a freaking leak here. So as you can hear, I think it's letting some water pass for some reason. Oh, I see a little bit of a drip here. So this is an electrical problem now, I think maybe. Let's try. So I'm thinking this was being weird because it was just had trapped air in it, so I'm just letting it run for a few minutes, see what happens. So the water is turned on. It looks like this died because it was letting through air and water. It's a little drip, but that's fine. That's because I just reconnected it to the top and that had water in it. So upon reassembly, I am having a bit more leaks. So what I'm doing is, I think it was leaking around this point. So I'm just putting TPFE tape on every rubber O-ring just to eliminate the possibility of irregularities in the fitting. I removed the old PTFE tape, and what I've done is I rewrapped it and put the PTFE tape under this line. You see where that brown part starts? Under it. because if you put under it, you're giving it, you're making it stick out more. So under it, where the rubber O-ring is. And what I've done was, so this is the tighter one, where this one is 1mm lower, and this one is 1mm higher. I think that was unnecessary, so move back to the original one, which is the original dimensions of the original piece, but reinforced. I think that one works actually better. No, I was wrong, so I'm trying the PTFE tape on top of the brown piece. I've got 7 full rotations on the rubber O-ring and the whole brown piece that's gonna lip over on the edge of that. And as you can see, we've got Fernox all around, with no PTFE tape this time. And the white one. Okay, and now we can fasten it in place.